All right, so we're going to take a look at some logarithmic functions, the domain, the range, and then we're going to go to Desmos. We're going to look at the graph really quickly. And we talk about how this applies. Now remember, the domain are the possible x values. The range are the possible y values. And so we don't want to have to deal with imaginary numbers. So what that means is, if we have a square root or root to the fourth power, or any root that is to an even number, it's possible that there are going to be numbers we just can't put in, because in this case we can't have what's inside here. It cannot be a negative, because that would give me an imaginary answer, and we just don't want to do that. So in this case, we are going to have a restriction in the domain, because we need to make sure that x minus 2 is not negative. So that means that x minus 2 has to be greater than or equal to, because we could equal 0. Well, that means x is greater than or equal to 2 in this case. So that's what our domain is going to be. X is greater than or equal to 2. Now, when it comes for our range, you'll remember that the range, y values, so we really need to look at what the normal function looks like. So normally a logarithmic function on the grid is going to start at 0, 0, and going to head this way like this. And so by subtracting 1, well, we're going to take this parent function and we're going to slide it down 1 value. So what is the limit? What's the bottom limit for this function? Well, it can't be less than negative 1. So we know that y is greater than or equal to negative 1. Now, when we look at the upper limit, is there an upper limit? Like, can this function hit a ceiling, so to speak? And the answer to that is no. It will go off into infinity. So that's kind of the deal that we have. So y is just going to be bigger than negative 1. And we'll take a look at the graph. And since we know x has to be greater than 2 and y has to be greater than negative 1, what that's going to do with our function is it's going to slide it over 2 spaces and down 1. So it's going to look something like this. And to make this 0, we're subtracting 1 from the whole thing, so that means this piece here has to be equal to 1. 1 minus 1 is 0. And so, well, the square root of 1 is 1, so that means it's going to cross at 3, right, where an x is equal to 3. All right, so looking at the second expression, same basic idea, except we have an odd number here. Well, we can have a negative inside a cube root. That's totally fine. So that means the domain is all real numbers. They will all work. And that also means the range is also going to be all real numbers. Because you'll remember a cubic function, a basic cubic function, is going to look like this. Well, when we have our cube root function, well, that's going to kind of lay it on its side, isn't it? So that's going to look something like this. If we have just a basic cube root function, I think it looks like that. Well, what's going to happen when we have a negative over here? Is it a negative? Yeah, it is a negative. Well, that means it's going to flip it on its side. So our actual function is going to look something like this, and now we're blinding your eyes. And so the question is, where does it go through the x-axis? And again, same basic idea. We need a cube root of 1, so x is going to have to be 6. 6 plus 3 is 9. The cube root of 9 is 3. No, that doesn't work. So we need to get the cube root of 1. So negative 3 times, or negative 3 plus 3 is 0. Yes. The cube root of 0 is, well, 0. Minus 1. We'll take a look at that in a second, because I get a little too far ahead of myself. So here's our last one. Get rid of that. All right, same basic idea. Now we have an even root that's not 2. And so we know that what's inside here cannot, oh my God, cannot be negative. So we know that x, goodness, I hate that yellow. So we know that x plus 1 has to be greater than or equal to 0, which means x has to be greater or equal to negative 1. So x has to be greater or equal to negative 1. And so then for a range, this is going to drop it down to, and so we're going to have all numbers that are greater than negative 2. And let's take a look at the graphs. All right, I want to go home at this point, so let's go look at the graphs. All right, so here we have in the red that first function. So just like we said, it's going to drop 1 space down and then 2 over, and it's going to go through 3, 0. So, and then it's going to continue to get higher as we go. For our blue one, this is our cubic root, and we have it slid over here to 4. Why is it to 4? Well, because the negative 4. So negative 4 times, or sorry, negative 4 plus 3 is negative 1. The cube root of negative 1 is negative 1. And, oh, because we're setting the whole thing equal to 0. Right, okay, so we have to set the whole thing equal to 0. And so negative 1 to negative is positive, so that's why that makes sense. Okay, I should have done a better job of that, but I'm just getting tired of it. And then this negative root of this nice thing is, oh my goodness, is that a negative? Oh shoot, it is negative. All right, so that's going to change my answer. Let's go over here. I totally missed the negative here. I'm sorry about that. So this negative means it's going to flip the fraction, or flip the graph. So instead of looking like this, it's going to look like that, which means x is going to be less than negative 1. And so that's what's going on. I'm sorry about that. All right. And so in this case, it's coming down to 2. Oh my goodness, why is it 2? That's a great question. Let's see. Oh, well, no kidding, it's down 2. Okay, so it's down 2, right? Because, so that's our range. I hope I had that for range. And so the x is, oh no, the x is still correct. I'm sorry. All right, no, yeah, we had it right. Except x, because of the negative, x had to be less than. Okay. So I kind of fell apart at the end. I'm sorry about that.